Hi and Assalamualaikum. I am Shamimi. So for today, I will be teaching you chapter 6 in form 3, angles and tangent of circles. As for today, we will only be focusing on two subtopics. The first subtopic is angle at the circumference and central angle subtended by an arc. And the second subtopic is cyclic quadrilateral. So now, let's move to the first subtopic. Students, do you still remember when you are in Form 2, you learn a topic circle? And specifically, inside the topic, you learn about properties of circle. So there are a few things you have to know before we go through chapter 6 for today. Okay, the first one, it is radius. Radius is from the center to the end of circumference. It is called radius. If we double the radius, we call it diameter. From one end of circumference to the other end of circumference, but it must go through the center. Then we call it as a diameter. Okay, next we have an arc. Arc is actually a circumference, but it is part of circumference. It is not all, but just part of the circumference. And as for chord, it is a straight line inside the circle, but it doesn't go through the center. So this one we call it as a chord. Next one is a segment. Segment is a shaded region inside the circle, but it doesn't go through the center as well. Okay, last one we have sector. Sector, we have two radius. And if we shade the region within the two radius, we call it as a sector. So the region in this green color is a sector. So do you understand all these properties? If you have a better understanding on this one, now we go into the first subtopic of chapter 6. First, let me introduce you with the angle at the circumference. Angle at the circumference happen if there is a point lies on the circumference. In this case, we have point A, and point A must be connected with two arms. So this is the arms. Okay, arm 1 and arm 2. Both arms are connected to the other point, which are B and C respectively. Only then you will get the angle at the circumference right here. In this subtopic, I would like to categorize into three properties. Now let's move to the first properties. The first properties is about angle at the circumference subtended by an arc. So here we have two circles on the screen, but let's focus on this circle first. In this circle, we will be having points that lies on circumference. We will be having D, E, and F. These points are connected with arms to point B and C. Okay, both arms for each points are connected to B and C. Hence, we can know the angle at the vertices. We can know angle at the circumference at point D, E, and F. They are all equal. This is because their arms are connected to the same point. Moving on to the second circle, we also have the vertices that lies on the circumference, and each vertices has their own arms, but their arms are not connected to the same point. As for A, the first arm is connected to C, and the second arm is connected to D. While for B, the first arm is connected to E, and the second arm is connected to F. In this case, if the angle at the circumference are equal, in this case it is 19, then the arc length also will be equal, which are 1.99 for both arc CD and EF. If we move V to be 50, then the arc length will be 5.24. and it is not equal to the arc length of CD. It will be 1.99. So we can let's move the angle U to 50 as well. Now we can see, now we can see the arc length of CD and EF are equal, which is 5.24. Now let's move on to the next properties. The second properties is about the relationship between the angle at the circumference and angle at the center. Now let's look at the diagram on the left first. Here we have angle at circumference at point B, and the value is x equals to 64.18. Let's look at the arms. The arms are connected to point A and point C. And we also have radius that are connected from center O to the point A and C. In this case, we can get the angle at the center, and the angle at the center will be double the angle at the circumference. So the angle at the circumference is x, hence the angle at the center will be 2 times x. Then we will get 128.35. Please bear in mind that the angle at the center you must take outside the quadrilateral. Now, can you spot a quadrilateral here? Yes, we have a quadrilateral. So the angle at the center must be outside the quadrilateral. If you move the point B anywhere you want, the angle are still the same. This is because the arms and the radius are connected on the same point. Okay, if we move A or C, then the angle will be a bit bigger, but the calculation is still the same. The angle at the circumference will be x, and the angle at the center will be 2x. Moving on to the second diagram, we have a circle with center P, and we have the angle at the circumference at point D, which is x equals to 117.07. Let's look at the arms. The arms are connected to point E and F, and we also have radius from point P. They are connected to point E and F as well. In this case, we can use the same relationship as the first diagram, which are the angle at the center will be double the angle at the circumference. However, we need to make sure the angle at the center must be outside the quadrilateral. So here is our quadrilateral. So our angle at center will be outside the quadrilateral. Hence, the relationship is 2x. 2 times 117.07, then we will get 234.14. If you move point D and make it the same as the first diagram, it will be a bit different. The angle here will be inside the quadrilateral. The relationship is applied if and only if the angle of the center, the angle at the center is outside the quadrilateral. So the 2x will be right here. Okay, so please be careful with these properties. It's a bit confusing. It's a bit tricky. Okay, but please bear in mind that the angle at center must be outside the quadrilateral. Now, let's go to the properties 3. The third properties is about angle in semicircle. The diagram at the left is semicircle, and the diagram at the right is the circle. In the semicircle, can you spot a triangle? Here is the triangle. Now, let's check. Where are the vertices? Oh yeah, the vertices all lies on the arc of the semicircle. Now, let's check whether the diameter are one of the sides of the triangle. Yes, it is. The diameter are one of the sides of the triangle. Hence, we can know in these properties, we can know the angle opposite to diameter is 90 degree. So here is the diameter, then the opposite angle is B. So here will be 90 degree. This is for semicircle. What about in the circle? In the circle, as long as we have the diameter right here, and we can spot a triangle. And the diameter is one of the sides for the triangle. And all the vertices lies on the circumference. Vertices A, B, and C lies on the circumference of circle with center P. Hence, the angle opposite to the diameter will be 90 degree. So that is all for the third properties. And we already finished with all the properties. Now, let's continue with second subtopic, which is cyclic quadrilateral. First thing first, let me introduce you with cyclic quadrilateral. What is cyclic quadrilateral? Cyclic quadrilateral exists if there is a quadrilateral inside circle. So here we have circle with center O, and we have quadrilateral inside the circle. Can you see it? We have quadrilateral and it is inside the circle. And we need to check the vertices of the quadrilateral. All of the vertices must lie on the circumference. If they lie on the circumference, then we can say this is cyclic quadrilateral. After we know what is cyclic quadrilateral, now we want to know the relationship between cyclic quadrilateral and the angle. For cyclic quadrilateral, the summation of interior opposite angle is 180 degree. Let me ask you, what is the opposite angle to LMN? LMN. So what is the opposite angle? It is NKL. The angle at the vertex M is opposite to the angle at vertex K. So, the summation of these two angles will be 180 degree. So, here I show you the calculation. Angle LMN plus angle NKL equals to 72.69 plus 107.31. And we will get 180 degree. If we move the angle, if we move point M, or we move point K, or we move point L, the angle are changing, but the summation are still the same. It's still 180 degree. Okay, now let me ask you the opposite angle for MLK. The opposite angle for MLK is KNM or MNK. If we sum up both value of the angle, 82.91 plus 97.09, we still get 180. Let's move point K right here. The angle for LMN, the angle at the vertex L and N are changing, but summation are still the same, which is 180 degree. And that is all for cyclic quadrilateral. So now we will do some quizzes to test whether you understand or not with this subtopic. It's a quiz time, so you are given 10 seconds to answer each question. For the first question, diagram 1 shows a circle. What is the value of x? The answer is 40 because you can find this by using the first properties that you have learned just now. The second question, given that angle IHG equals to angle MLK, what is the length of arc KM? The answer is C, 7 centimeter. You can find this by using the first properties as well. We have BC is the diameter of the circle. Given that angle ABC is equals to 25 degree, find the value of angle BCA. This one you need to do a bit calculation. The answer will be D, which is 65 degree. By having the sentence that mentioned BC is the diameter, we know opposite to BC is 90 degree. So here is 90 degree. And given that ABC is 25, so one triangle we have 180. Hence, to find ACB or BCA, we can subtract 100 minus 90 minus 25. Then we will get 65. The last question for the quiz. Okay, given that angle DBA equals to 72 degree, find the value of angle ACD. The answer will be B, 108 degree. This is because if we sum up both angle, we will get 180 because ABCD is a cyclic quadrilateral. So the summation of interior opposite angle will be 180 degree. We already finished answering the quiz. Now let's proceed with our exercise. But let's do this together. The diagram shows a circle with center O. And PR is the diameter. So this is PR and it is a diameter. So given that QST is a straight line, if the equation mentions straight line, then you know a straight line, the total angle for a straight line is 180 degree. And angle PST is equals to 102 degree. Find the angle of PRQ. So we know the angle PST. Here is the angle PST, which is 102. Now we want to find PRQ. So to find this, can you see a few shapes that we have learned before? Okay, the first one we have triangle. Okay, we know that is the triangle. Now let's check. Are the vertices lies on the circumference? Yes, P, Q, and R lies on the circumference of the circle. Now let's check whether one of the sides are the diameter. Yes, the question stated that PR is the diameter. Hence, we can know that angle of PQR is 90 degree. Now, let's check whether there is another clue or hint for us to find our answer. Alright, so can you see the quadrilateral here? There you are. POTQ are the quadrilateral. And there is a point or vertex, which is vertex Q, lies on the circumference, and it has two arms. And each arms, the first arm is connected to T, and the second arm is connected to P. And we have a radius as well, where the radius connected to P and T. So can we use the first properties? Yes. Okay, now the question already given the angle at the center. We know angle at the center is double the angle at the circumference. So we know now the question already give us the angle at the center. Let's find the angle at the circumference. To find it, we need to divide by 2. So the angle of PQT or TQP, can we know the angle? Okay, this one. SQP. I take it until this one. Or you can write it as PQT as well. So this angle we get as 59 degree. Now we want to find PRQ. So this is PRQ. How to find that? Okay, so QST is a straight line. QST is a straight line. And we already know the angle of PST. So can we find the angle at PSQ? Yes, we can find PSQ by 180 minus 102. So we will get this angle. However, you also can use the properties of vertical opposite angle. So you can get RSQ here is also 102. Okay, since we know PQR is 90 and this PQS is 59, hence we can find SQR. SQR is 90 minus 59, so we will get 31. Okay, so now we can get the angle SRQ. So now we can get the angle SRQ, which is 180 minus 102 minus 31. Then we will get 47. SRQ is also equal to PRQ. Hence, we already get our answer. The angle of PRQ is equals to 47. Okay, so there are many ways for you to find the answer. Just like I've said just now, you can find PSQ by subtracting 180 and 102. Then you will get this one, this angle. Then you can find this angle by 180 minus 59 minus this angle. Then you will get angle SPQ. Only then you can minus 180 minus 90 minus angle SPQ. Then you will get PRQ. So there are many ways to find the answer. Before we end our lesson, let's sum up on what we have learned for today. In 6.1, we have learned three properties. The first one is angle at circumference. If you have different vertices, let's say this is A, B, and C. Each of the vertices contain two arms and their arms connected to the same point. This is D and this is E. So their arms are connected to the same point. Hence, the angle at circumference here, let's say the value is X. The angle here will be X. Here also will be X. The second one is angle at center, and it has relationship with the angle at circumference. So let's say this is angle at circumference with value Y, and the arm, one of the arm are connected at point, this is A, and another one connected to point B. We also have radius that are connected from center to point A and from center to point B. Hence, we can find the angle at center here, or we call it central angle. The value here will be double the angle at the circumference. So if the angle at circumference is Y, then the angle at the center will be 2y. Remember, to choose the angle at center, it must be outside of the quadrilateral. The third properties we learn is angle in semicircle. Let's say we have a triangle here. We have a triangle, and one of the side for the triangle are the diameter. This is the diameter. Hence, the opposite angle to the diameter will be 90 degrees. So that is all for 6.1. In 6.2, you learn about cyclic quadrilateral. What is cyclic quadrilateral? It is quadrilateral located inside the circle, and all the vertices lies on the circumference of the circle. And the relationship between cyclic quadrilateral and the angle is the summation of two interior opposite angle will be 180 degrees. So here if we have x degree, and the opposite to x we have y. So x plus y will be 180 degree. If this is A and it is opposite to B, so the summation of A and B will be 180 degree. So that is all for our lesson. Till we meet again. Thank you. Assalamualaikum.